Hi there, my name is Yaro V. Garcia, and my project proposal is the wearable health monitoring device for hypertension and pyrexia detection from the wrist. Background: why the need to monitor hypertension and pyrexia? The number one leading cause of death in the US is heart disease. Now, heart disease is very well associated with hypertension, which is high blood pressure. For body temperature, during these COVID times, we have to make sure that our body temperature is at a stable state and not in a pyrexia state, which is a fever. Current monitoring device. Current monitoring devices, such as a sphygmomanometer and a laser thermometer, are used to obtain data for body temperature and blood pressure. Though these are very accurate devices, they are not wearable for everyday use. Here is some later work that shows that we can get accurate measurements of blood pressure and body temperature from the wrist. One way of blood pressure accurate readings is to get it from the radial and ulnar arteries, which are located at the wrist. As well as when comparing forehead and wrist body temperature readings, it was shown that a small difference of 0.55 degrees Celsius was shown between the two. And such methods as pulse wave velocity have been used to measure blood pressure with a tighter standard deviation of 0.4 millimeters of mercury compared to that of standard blood pressure measurements. Objective. The objective of this project is to create a wearable health device worn on the wrist to measure blood pressure and body temperature in order to detect hypertension and pyrexia. The device will be integrated to an existing smartwatch to take advantage of the sensors and software already available. Major deliveries. Experimental data to prove sensor functionality will be the first major delivery, such as selection of sensor accuracy, as we will test the sensors individually, and sensor integration. Number two major delivery is to create the CAD model and prototype. This will consist of wrist ergonomics, sensor fitting and placement, and producing the watch band. Evaluation metrics. Number one, accuracy of body temperature and blood pressure data compared to standard measuring devices. Number two, reliability of the watch band sensor readings at fluctuating ambient temperatures. Whether it be at cold and hot temperature, the watch band sensors must give out accurate readings. And number three, ergonomic design. Does this design allow the user to perform everyday tasks? Can the design be used while sleeping? Methodology, prototyping. The watch band will go through several iterations to include fit on wrist durability and ability to hold sensors. Iterations will change type of material, location of sensors on the watch band, and type of locking mechanism, such as a buckle or Velcro. Methodology experimentation. The band and sensors will need to be proven with real body data of blood pressure and body temperature. The first set of experiments will use volunteers to take steady blood pressure and body temperature data and comparing them with real-time medical devices like a thermometer. Second round of experiments will be to get volunteers that have hypertension and pyrexia and perform the similar comparisons as the first set of experiments to get accurate and concrete data. We have three anticipated challenges: the inability to acquire funds to create, prototype, and purchase sensors, being unable to find participants for a trial run data, and the inconsistent sensor readings. Some contingency plans for those goes as follows: cutting expenses and use my own smartwatch as part of the prototype, use it on myself and colleagues, and acquire different types of sensors for temperature and blood pressure readings. Preliminary work. Here we have a 3D CAD design of the watch band. Determine the sensor position to obtain consistent readings. The sensors will be positioned at the bottom of the wrist. This allows easy access to the radial and ulnar arteries. The watch band design is made up of a double loop system, which will allow the user to consistently place the sensors at the bottom of the wrist all the time. And you use for micro adjustments by using a Velcro system on the straps. The watch band inner circumference was determined to be a minimum of 5.25 inches and a maximum of 7.25 inches when comparing data using wrist size of men and women. Here we have the overall Gantt chart of how our breakdown of the project will consist of, as well as the overall arching Gantt chart through the months of January through July. Some resources that are needed. Here we have stated 6 of them. the thermal sensor, the pulse wave velocity sensor, access to SolidWorks, access to Swift, which is a software program to code in smartwatches, the watchband prototype, and volunteers. The significance of this project is to create a wearable health device worn on the wrist to measure blood pressure and body temperature to detect hypertension and pyrexia, to help those that struggle with maintaining and noticing any health readings. This wearable watch can be used to show body temperature is normal during COVID times. As we know, some buildings now require temperature readings when entering in such buildings or such places. And the ability to know in real time that the body is in normal state or in a dangerous state would allow ample time to seek medical attention